In this video, we're going to go through the workflow to construct MRM profiling lists using the lipid maps database. An MRM scan is composed of a parent and a product ion. Using this information, you can get for the phospholipids, as an example, the information for the lipid class, as well as the total number of carbon and unsaturation in the fatty acid chains of this lipid. There are four main steps to put together an MRM list. First is to go to the lipid maps and download the entries of the class of interest. Then you combine its isomers. Next, you calculate the ionized parent ion. And the last thing to do is to calculate the product ion using the neutral loss and precursor ion information for that specific class. In the lipid maps, you go to Resources, Databases. In the lipid mass structure database, go to Browse Search, go to Keyword Ontology. In this page, you can select the lipid class of interest. We're going to do glycerophospholipids, and we're going to pull the glycerophosphocholine. When you submit, the system will pull all the lipids in this class. In this case, it's 1780. You can fortunately download all the results in the Excel table. Here it is. Then you have the common name and the mass, which are the main information we need to do that. We organize the list by the mass so that we can easily identify the isomers. We're going to use a very common phosphatidylcholine as an example. This is the 759 molecular weight. So we're going to highlight it to make it easier to see. We can see 29 entries for the mass 759.6. And when you look at these masses, at these entries here, we see clearly that they are all isomers. So all these PC lipids have 34 carbon in the fatty acid chains and 1 unsaturation. The way we do in our lists is we just sum the carbon and the unsaturation, and then we combine this all together into one entry. So we're going to delete all the other entries. These other lipids that have similar weight, they are plasmalogens, and they have odd number of carbon in their fatty acid chains. Because we're dealing with mammalian cells and odd chain lipids is not common in this type of sample, we have eliminated from the method, but it's possible to keep them depending on the application of interest. So you saw that from 29 lipids, we're down to 1 entry here. The next thing we're going to do is to calculate the ionized mass. So these lipids get protonated. So we just add 1 unit of mass. We're dealing with a low resolution instrument. And now it's the fragment. So every phosphatidylcholine will give a fragment of mass 184 because this is the phosphocholine head. So this is our MRM. When you do this for the whole list, you will get this. Here we're showing the method in the instrument. So you have the precursor ion that you got from the lipid maps, the product ion that you calculated, that you used the information to figure out of the precursor neutral loss scan, and then you have collision energy fragment. We are using dwell time of 25 milliseconds. So this is what you're going to upload in the instrument and monitor with direct injection. Thank you for watching this video.